This video is primarily intended for some of my students, but I'm making this available more widely in case it's useful to other people. So we'll start off with a tangible example first of all, just to try and understand this gist. In this example, I've highlighted some findings in the literature. They might be slightly contested, but in general, a number of papers now have suggested that this kind of behavioral economic construct called discounting influences or is correlated to your body mass index. Now, for our purposes, we don't need to know much about discounting, but in short, you could think of it as a form of impulsivity. More accurately, if you score highly on the discounting measure, you would prefer smaller, sooner rewards over larger, later rewards. But if you score low in discounting, that would mean you prefer larger, later rewards over smaller, sooner rewards. And so people have explored this relationship and they have argued the case. Certainly not all papers have found a relationship, but many have. And so this is what we're going to consider in this example. Now, when we think about how your temporal preferences might affect your body mass index, we can kind of think, well, actually, how does this influence it? I can't think of any really obvious way how a set of preferences directly, and that's the key kind of word here, how discounting preferences directly affects your body mass index. Instead, it might be much easier to think about this in terms of the bottom figure, where now we have kind of hypothetical arrows linking discounting to body mass index, just as we did before, but we now also have this mediator, which could be a measure of behavior. We're not going to talk about, what behavior. You could think of any number of behaviors, but the hypothesis here would be that your discounting score that you exhibit may well influence your body mass index, but that is being mediated through a particular behavior. And so a mediation analysis aims to test this idea to say, to what extent is there evidence that your behavior of interest mediates the discounting BMI relationship. So when you look at mediation analysis in textbooks or in papers, the language will obviously be very general because not everybody is interested in exactly the same variables as you. So in general, people will talk about a predictor variable X and how that might be related to an outcome variable Y. So, yep, we could have a direct relationship between X and Y, but depending on your particular data set, your particular research question, your domain that you're looking at, you could hypothesize whether this relationship is either fully or partially mediated by something else, which we will call the mediator. Now, I want to be kind of clear. People have been perhaps a bit slack in the way how they write down the results or the conclusions that they draw from mediation analyses. The diagrams here are suggestive of causal influence. And so, we have these variables in boxes and we have arrows going in a particular direction. And so there is an implied direction of causality. And what I want to make clear on this slide is that this, unless you have done really special things with kind of complicated causal inference and experiment design, then you really should refrain from concluding that you have perhaps proved that there is a certain causal pathway, between a predictor and a mediator and an outcome variable. So instead, I think it's more kosher to be able to basically say that you have found a statistical description of your data, and you either have or you haven't found evidence for mediation. Now, that's not bad. I think that's a vital and important step in an ongoing larger picture of proving a causal relationship. Now, of course, one of the very important things that you would want to do is think about what these variables are and think about what the plausible causal pathways might be. And that contrasts to collecting a bunch of data and just running a whole load of analyses that you haven't really thought about. If there is no plausible, compelling reason to suspect mediation, then there's no real point in running a mediation analysis. So even though you might be running a mediation analysis because you have theoretical ideas, you have theoretical motivation, which is coming from a causal point of view, that X influences the mediator, which influences the outcome variable, you need to be a bit careful about how you describe the results. As a side note, I just wanted to mention that you can have kind of full or you can have partial mediation. So we'll talk about this in a bit more detail later. But now it could be that once you include the mediator, the kind of direct relationship between X and Y essentially disappears. So another way of saying that would be that the mediator accounts for all the variation. But it could also be that actually there is evidence that the mediator plays a role, but that there is some remaining unaccounted for relationship between X and Y. Now, it could be, so this is where thinking comes in, it could be that X does actually directly influence Y, even though it also does it through the mediator. But another interpretation could be, well, maybe there are other mediators here that I haven't thought about and haven't included. So that's just an interesting aside for thinking about whether you want to include kind of one mediator, which is probably the best in most cases, or if you want to include multiple mediators, and that completely depends on your research question. Now, how do you go about doing the mediation analysis? I have to say, when you start learning about this stuff, it is not presented in the most clear way, to be honest. So I think what I'd like to say is that if you can understand a straight line and the equation of a straight line, then you can understand mediation, no problem. So hopefully the rest of this video will make this clear. So in this picture, we've just got a recap. You might, if you don't feel comfortable with it or remember everything about linear regression, you might want to take a quick look at this. But basically, the equation that is often given is y equals mx plus c plus some error term. Now, this is what you will kind of most often see written in books and papers. The exact symbols might change, for example, the letters might change, but if you have your predictor variable, which is being multiplied by a slope, and then you also have an intercept, then you're doing linear regression. Personally, I much prefer this notation on the bottom here, which can be read as y is normally distributed around this kind of mean value, which is determined by your mx plus c, so that's the equation of a straight line, and it's normally distributed with a certain standard deviation. Now, if that confuses you, just forget about it. But personally, I much prefer this notation. It makes things much more explicit in my mind. In particular, the distribution of data around the straight line. Now, there are a number of different ways of proceeding, and I'm going to kind of outline the Barron-Kenny approach, and I'm taking all of this from a paper which is cited in the bottom here. So the first step under their approach is to not dive straight into mediation, but first of all, you obviously want to establish that your predictor variable x and your outcome variable y is actually related to each other, are actually related to each other. So you might want to, you could look at that through a correlation, but it kind of makes sense to do a linear regression here. And so you'd be saying, is there a main effect of x upon y? Now, if there is a relationship between x and y, you can then proceed to the mediation model, where you're going to test the idea of whether that relationship is fully or partly mediated by your mediator. So the first step is, if you look at the diagram on the bottom right, is to essentially test whether your predictor variable is related to your mediator. How do you do that? Well, it's simply another linear regression. We have the slope here, which is shown as alpha. So your predictor variable is multiplied by the slope alpha, and you have an intercept term. The third step is then to show that your outcome variable y is predicted by both the predictor variable x and the mediator m. And so this equation gets slightly more difficult, but now it is still linear regression. Technically, you might want to say it's multiple linear regression. All we're saying now is that if your statistical task was to predict the outcome variable y by the predictors m and x, then we want to evaluate what the slopes are. So these will correspond to main effects in a multiple regression analysis. So if you show those things, then that's all fine. You've basically gone a long way to demonstrating mediation. But then you might want to basically work out whether there is evidence for full mediation or partial mediation. So I think the best way to kind of think about this is to say, well, should I kind of delete this line here, which is labeled as tau prime between x and y? Is it that all of the relationship between x and y can be accounted for through this mediator? If so, I can maybe remove this direct arrow here and claim that there is evidence for full mediation. If not, then you've basically got evidence for partial mediation. And so, yes, the mediator that you have can explain some of the variance, some of the relationship between X and Y, but there is also additional variation between those two which cannot be explained by the mediator. And we talked a couple of slides back about how if we're to interpret this causally, it might mean that there is actually literally a direct effect left, or it could also be interpreted as maybe there are other mediators that I need to be thinking about here. So just to clarify some of these terms, the direct effect is evaluated, it is basically the slope of a regression line between X and Y. So when you do your multiple regression where you're trying to predict Y by the mediator and the predictor, the direct effect is given by this slope of labeled as tau prime. The indirect effect is also known as the mediation effect, and so this is basically if you take the slopes alpha and beta and multiply those two things together, people often label this as theta. That will basically tell you the total effect of X on Y through the mediator. We also have the variable, the term total effects, and that is basically the sum of the direct effect and the indirect effect. And so the total effects could be thought of as how strong is this relationship between X and Y, both directly and through the mediator. So those are just some terms which are used quite often, and I think that in becoming more fluent with mediation models, it's good to basically burn this image onto the back of your retina, and I just find thinking about these things visually much easier. So the terms direct, indirect, and total effects can just be a bit kind of confusing if you just think about that in the abstract. But if every time you read direct effect, you conjure this image to your mind and you think, aha, well, that's the arrow between X and Y, then I think that will help. So when you look at these effects, it's important to kind of work out how to interpret these. Now, this all depends on what the options are that you have selected when you run these meta-analyses. If you were to run, mediation analysis, if you were to run the mediation analysis on the raw data, the parameters you get, the slopes of these regressions are going to be unstandardized. And what that means is that you might get particular numbers out for these direct and indirect effects and so on. And there's no real way for you to know whether these things are large or small, because it entirely depends on whether your variables that in your data set consist of like a set of large numbers or a set of small numbers. And so quite often what you might do is you'd click standardize, which, as far as I understand, is basically equivalent to just z-scoring all of your columns of data. That's maybe the way how to think about it. And so now all of your data is standardized to have an average, a mean of 0 and a variance of 1. And so when you run your mediation analyses, the direct and indirect effects and so on will be, the numbers will be different, but they will be much more interpretable. So you could, more easily write about whether these effects are kind of large or small. Now I'm going to go through briefly an example that I've done with simulated data. So what I've done is to simulate a data set of 100 participants where there is a true direct effect and there is also a mediation effect. And I've just visualized this data by plotting each of the pairwise combinations. And so the panel on the left shows the relationship between the predictor X and the outcome Y. So that's good. We would want to do a regression on that in our first step to see if there's a significant main effect there before we proceed. But then what we might want to do if we're doing a mediation analysis is to check if there is a relationship between X and the mediator. If there is no kind of relationship, then probably won't have much luck with the mediation analysis. Finally, in the final panel, we have the relationship between the mediator variable and the outcome variable. And again, it just makes a lot of sense to plot these with your particular data set so that you can get an intuitive look at the data and a bit of a feel for the data. Now, this is a bit of a busy slide, but basically what I did was with that simulated data, I ran this through a mediation model using JASP, which is a really nice free piece of software, which is way better than SPSS. Now, if we look at the table on the left here, we can see that you get reports of direct effects, indirect effects, and total effects. So these are the things that we've just talked about. On the kind of right middle, we also see a nice kind of path diagram. And so what we can see, if you look at the path diagram and then you look at the tables, this kind of helps you to interpret what's going on. So the direct effect is the one between X and Y, and we see that that's labeled in the path diagram as 0.76, and we can see that that matches up with the top table called direct effects in the estimate. So that's to 3 decimal places, which rounds to 0.76. Now, the indirect effect, remember this is alpha times beta, and so we can see on the path diagram that alpha is 0.57 and beta is 0.74. So if we multiply those two together, that shows you the overall mediation or indirect effect, and so that's shown in the second table. And of course we can see our hand calculation ends up at 0.42, and that's also shown in this second indirect effects table. And the total effects is basically the sum of the direct effect and the indirect effect. And if we work that out by hand, we get 1.18. And that indeed is what matches up with what we find in the total effects table. And just bear in mind that I did not click on the standardization button. And so we have to kind of bear this in mind when we look at these numbers and interpret what they mean. That said, one of the important things is, are these effects significant? And we can, in a statistical sense, and we can say that yes, all 3 of these effects are shown to be significant at the 0.01 level. We can also look at the 90% confidence interval, and in all 3 tables we can see that these confidence intervals do not overlap with 0. And so for this particular example, you could say we've got evidence here for both direct effects of X upon Y, but we also have evidence for the indirect effect or mediating effect. I might have been slightly sloppy with exactly how I have phrased that, but this is a frequentist test that's done in JASP at the moment. As far as I understand, you can do standard frequentist statistics using mediation analysis in JASP, but at this precise moment, I don't believe you can do a Bayesian mediation analysis in JASP. Okay, one of the nice things about JASP, so you can see here, this is what it looks like if you have not seen JASP before. It's very user-friendly. One of the nice things about it is it's easy to add multiple mediators. I've not done that in this example, but that is something that some people might want to do, and so it's easy to do in JASP. It's also nice because if you click the option here to get this Lavaan syntax, you will then get a printout on the right of the mediation model. It uses this certain notation. Now, for the majority of my students, I think that this is going to be kind of irrelevant, but some of you might graduate onto path analysis to look at slightly more complicated variables, slightly more complicated models, and so doing that, getting the model syntax is useful in this case because it gives you a starting point from which you can add in additional variables in particular ways you want, but I'm not going to delve into that deeper in this video. It's important to note that there have been some criticisms of mediation analysis. So I basically took this directly from this 2010 paper cited here. So a direct quote. Sobel's 1982 method often exhibits type 1 error rates that are too low, which seriously affects its power to detect a mediational effect. So using frequentist methods has proven problematic, and on my Twitter feed I see a lot of criticism about mediation analyses. This paper also shows that there are different ways of going about this. There's a method called bias-corrected accelerated bootstrap methods, and to be honest, I don't know exactly what that means. But the paper, I know what bootstrap methods mean, but this particular one was seen as not so good. However, that paper does report that hierarchical Bayesian methods, which are not available in JASP at this point, but also bootstrapped percentile confidence interval methods did work well. And the screenshot on the right here shows that, as far as I understand, it's pretty clear, pretty obvious, you can opt for this approach in JASP. So it pays to be aware that there are some criticisms of mediation models, mostly revolving around error rates and power. If you go on to do Bayesian versions, then we might overcome some of those things. Speaking of which, this isn't so much a criticism insofar as it's just an interesting point. So Yuan and McKinnon, 2009, published an interesting paper about how to do Bayesian parameter estimation, and I've kind of implemented some of this stuff, and it's actually not very difficult for those of you with the kind of appropriate background. It's really not that tough at all. But a particular criticism or point of note here is just to say that these Bayesian approaches are very good at parameter estimation, and so if your goal is to establish the strength of direct and indirect effects, for example, then that's great. But it might be for your problem that you're particularly interested in evaluating the kind of discrete hypotheses of, do we have evidence for a direct effect model? Do we have evidence for a full mediation model? Or do we have evidence for a partial mediation model? And this paper in 2014 argues that using the approach of Bayesian parameter estimation isn't so appropriate for the specific task of hypothesis testing. So I'll be completely honest and say that I'm not quite sure why, because I think that these are basically sub-models of each other, and I'm not completely sure why you can't use the Savage-Dickey method to find evidence for these different sub-models, but that's simply because I've not looked into it enough. So we'll end just on a couple of slides of resources. So the first thing I'll mention is I've written up a Bayesian mediation model, and I've got that on my GitHub page. I'll make all of these links and references available in the description of this video. There's also a paper here which we just talked about, which this paper does come with an R package which allows you to do hypothesis tests for mediation models. And the reference at the bottom here is a good one on Bayesian mediation analysis, and so I was kind of inspired by that one when I wrote up my code to do that. The Wu and Zumbo 2007 paper is a really interesting one. It's good to have a look at to get some basic background. And finally, just talk about some software. We've got Lavaan, which is, so I mentioned the Lavaan syntax. This is basically structural equation modeling, which this is an R package, but JASP essentially constructs the model syntax from what you've done in its interface. So if you were to do anything more fancy, the first thing would be to start with JASP and do mediation analysis, but then you could use the structural equation modeling tool to add in your own information. But of course you'd want to understand a bit more about the Lavaan syntax. Now there's a package called Lavaan, which is the Bayesian equivalent of doing that. So I thought I'd just put the corresponding link and paper here as well. So hopefully that has been a useful introduction to meta and I keep on getting those confused. Mediation analysis. Like I say, this video was intended to get my students up to speed. If you're a professional statistician or have years of experience with mediation analyses, then I'm not sure you would have got anything from this video, but I hope it was interesting.